All right, the next subject, and this will be the shortest one, I think, we're going to talk about half-life. Half-life, by definition, is how long it takes for half of a radioactive substance to decay. So we had that one video, we had like uranium, 238, and 92. It decayed through alpha decay, if you remember, to 234 and 90. And that was TH plus this alpha particle we called He42. Half-life would be how long it took for half of this to turn into that. All right? Half-life is kind of unique in that it's a substance or a math equation that never goes to zero. It has an asymptote, if you remember that term. It means it gets really close to zero but never really does touch zero. All right. The typical, and this isn't drawn really well, I'm not really good at drawing parabolas, but the typical half-life graph, which you'll have to interpret, will look something like this. It'll have either like the percents or amounts, and it'll be times 0, and then like 1, 2, 3, 4, 5, 6, 7, and it'll keep going. And you would be asked to look at this graph and to determine what the half-life of this substance is. And it's really simple. You just go from whatever you started with to half of whatever you started with, and it intersects right here. And so I'm just estimating, so we'd say like 2.25 days is how long it would take for half of this substance to decay. Now, once you found that number, they will generally ask you a secondary question. It'll say, all right, just with this graph, how many will you have in 6.75 days? All right, so you'll find the half-life, and then they'll ask you to use it. If we're at 6.75 days total, we just take this and divide it by 2.25 days. And if I did this right, that should equal 3. And this would tell you the number of half-lives. It's pretty simple. So if it's gone through 3 half-lives, it's gone from 100% to 50 to 25 to 12.5. These arrows were representing the half-lives it's gone through. So in 6 3/4 days, we end up having 12.5% of our original isotope left, which could be something like uranium, even though uranium has like thousands of years as a half-life. This is the process they use when they do carbon dating. They know, and I don't remember the number exactly, but they know that carbon-14 goes through a decay process, and it takes 5,000, I think, 143 days or years, I mean, for half of it to decay. So what they'll do, they'll find an old living thing, and they'll look at what percentage of carbon-14 it has now compared to what living things now have. And it'll say, all right, well, it's 25% of what we would expect it to be. So we go to 100 now. 25 goes to 50. 50 goes to 100. It's gone through 2 half-lives. Sorry, boxing the arrows. And that would mean that it's gone through 2, so that whatever you were looking at was 10,000 years old. Okay? It's half-life. Just for sure, know how to read the graph. You just find where half of it has disappeared, and that's how long it took. Easy enough, I hope. That's half-life.